So I record it here. All right. So first of all, significant figures. So in chemistry, we talk about significant figures. So in this course, as well as in Chem 106, we talk a lot about significant figures. So what is significant figures? So if you have a numbers, which numbers are significant figures and which numbers are not which digits are significant figures and which are not. So we just want to find those. So let's I'm going to write one number here. 0. I have a number here. 0, 0. There are 4 zeros. 4 zeros, and I think there are 5 zeros. 1, 2, 3, 4, 5 zeros, then 3, 0, 0, 0, 2, 0, 0. Let's say you have a number like this. So you measure something, and your balance or something like this, right? So which number are significant figure and which digit are significant figure and which are not? So that we need to know here, yeah? So here is a decimal. So if there is a decimal, all these zeros, the front zeros, the leading zeros, we call leading zeros, they are not significant. So if you see any number like that and there are leading zeros, they are not significant, yeah? And every other thing is significant. So how many significant figure in this number? 1, 2, 3, 4, 5, 6, 7. So this is a 7 significant digit there in this number, yeah? So let's write another number. So this is a 7 significant figure number. Now let's write another one. So something like this. So we are not going to measure something that big or that small in the laboratory, right? So let's say I measure something and I got 2500 gram. So how many significant figure here? So this is a leading zero. So this is not significant, and every other thing is significant. Yeah. So 1, 2, 3, 4 significant figure. This is 4 significant figure. Yeah. So let's write something another one. 0.025. So how many significant figure here? So again, this is a leading zero, not significant. This is also a leading zero, so there is no number before this, right? So these are not significant. So 1, 2, there are 2 significant figures here, yeah? So let's write another one, 0.0205, something like this. So the front zeros, these are not significant. So this is significant, this is significant, this is significant, right? See that? So there are 3 significant figures. So if I write another 0, this is also significant. So the 0 behinds are all significant. Yeah? Make sense? So these are how many significant figures here? 1, 2, 3, 4. 4 significant figures. Yeah? So that's how we do. And so I just put one example there. So one example is sufficient. Once you know that one, so you know everything there. So another one. So let's say you have a scientific number in scientific notation, 1.27 10 to the power. Here is a number 24. So something like this. See, so this is called coefficient. This is the number of space in scientific notation is like this. So this is called coefficient. So only the coefficients are the significant. So there are 24 zeros here and 3 number here. So these things we don't consider significant. So how many significant figures here? Only 3. Yeah? Only the coefficient is significant. Now let's write another number, 2.50 10 to the power 3. So again, these 3 are the coefficient and these are not significant. So 1, 2, 3 significant figures. Make sense? So that's the rule of significant figure. So we don't have many rules, just that many cover all rules. Yeah. So, now, so only 3 significant figures here. 1.27 is significant there. Now let's talk a large number like this, 3,000. No decimal. No decimal. I have a 3,000. No, 12,000. I have 12,000 in my note here, so I just write that 12,000. There is no decimal here, right? So this is like 12,000 miles. Somebody drive the car and he say, oh, I drove 12,000 miles. So which number are significant here? So if this is a big number like this, and there is no decimal here, and these are not significant now. So only 1 and 2 are significant. So this is a 2 significant figure number. Make sense? But if something like this, so 12.000, so how many significant figure here? This is a 1, 2, 3, 4, 5 significant figure number. Yeah? But if this is a large number, no decimal there, 12,000 there, like this. So those zeros are not significant. Make sense? But if there was a decimal here, definitely all these zeros are significant. Make sense? Good. Now, so that's it. Now let's do. There are some rules of addition and subtraction. Yeah, we all did this addition subtraction from early childhood, but here are some rules how to do addition and subtraction, including significant figure. Yeah. So let's do some rules of addition and subtraction. Addition and subtraction. So this will be an exam. This will be in Chem 106 laboratory as well as in this exam. So you will see 5 to 10 points or maybe 15 points in exam in addition and subtraction and this kind of calculation using significant figure. Yeah. So this is important for exam too. So here is a number. So I have 14.23. So I go to lab and start to measure the mass. So I measure one mass 14.23 gram, and I measure another 8.14 gram. 8.14 gram. I measure another mass, and this was 6750 gram, and I measure another mass that was 120.4 gram. 4 gram. Now I need to add all mass together, right? So how many mass I have? I go to lab and I measure the 1, 2, 3, 4 mass here. Now I need to add these masses together, right? So if I add these mass together, I will get something like this. I put in calculator, and the calculator gives me something like this, 139.0923, something like this. The calculator gives something like this, yeah? Now, if in another course, like in the higher level course or other kind of course, you just put this number and you are done, right? So you know how to do addition. But in this course, what I say is, add this number and report your answer with the rules of significant figure. So this is not the right answer. You see that? Now we need to take care of the significant figure here. So now how many decimal here? 1, 2 decimal. How many places decimal here? 1, 2. Here 1, 2, 3, 4. Here only 1. So the answer should be, when we are doing the addition or subtraction, the answer should be with the least decimal place. Yeah. So it should go. The answer should look like the number which has the least decimal places. So there is only 1 decimal place here. So my answer should not look like this. It should look like this. See that? 139.0. Why? Because this is 1 decimal place. So my answer also should go with the 1 decimal place. Make sense? Yes. Yes, second round, I will talk about that one. But at this point, I didn't talk about the rounding. As long as you know this one, you're good. So there is a least number of decimal places 1. So my answer should look like 139.0, 1 decimal place. So why is that? Because you see here, this is very accurate measurement. 3.6750 is a very, very accurate measurement. Yeah. This is also accurate because 2 decimals. This is also accurate. So this is the least accurate, 120.4. This 1 decimal place is the least accurate measurement. So our answer cannot be more accurate than the least accurate measurement. That's the rule. Make sense? So this is the least accurate measurement because there is only 1 decimal. So my answer cannot be more accurate than this one. So just 1 decimal. Make sense? Good. So that's the rule. Now, so it should look like this. Now let's do another one subtraction. Same. So there is, I put another problem there. Example there, 4.23. I may measure a mass one time, 4.23 gram. And I measure another substance, and this was 3.1 1 gram. So now I am going to subtract this. What is the mass difference here? So that is 1.13. So this, your calculator will do something like this, right? But this is not the answer in this class. Yeah. So what is the answer? I have 2 digits here after the decimal here. Here is only 1 decimal here, right? So this is my least accurate measurement. So my answer cannot be more accurate than this one, right? So my answer should be 1.1 gram. So I put the homework in the software. So if you click 1.13, you get 0. If you click 1.1, you get 5 or 100 out of 100. You see that? So this is just the trick. Make sense? Good. So this is not the answer. This is the answer. But in all other classes or in daily life, it doesn't matter, right? Either you write 1.13, 1.12, 1.01, it's the same thing, right? But in this class, we do something like that, yeah? Probably you never study after finishing this class, this kind of thing. Now let's talk another one. So now multiplication and division. We just finished the subtraction and addition. Now we talk about the multiplication and division. Multiplication and division. Multiplication and division. So here is one number, 41.24 grams. So I measured 3 masses here. One was 41.24 gram. Another was 6.01 gram. And I also measure another mass, and I wanted to divide by the, so that was 22.03 grams. So I have 3 masses, and I'm just trying to multiply and divide. So this and this multiply, and I'm going to divide by this one, right? So this is a multiplication division rule. So this is, when it is down, it is a division. So in this case, if you put this number in calculator, you will see something like this, 11.11445. So put in calculator these numbers, and calculator gives you that answer, right? Now we need to take care of the significant figure here. So look the least number of the significant figure. So in the addition and subtraction, I was looking the least number of decimal place, right? So here I'm trying to see the least number of significant figure. So how many significant figure here? 1, 2, 3, 4. This is 4 significant figure here. 4 significant figure. How many significant figure here? So this is a middle zero. There is always significant, right? Only front zeros are not significant, right? So this is a middle zero. So 6 here. So this is not leading zero. Leading is 6 here. So this is 3 significant figure here. 3 significant figure here. How many significant figure here? 1, 2, 3, 4. This is 4 significant figure. So my answer should look like the number with the least number of the significant figure. So in addition and subtraction, the least number of decimal place. In multiplication in division, least number of the significant figure. So how many significant figure here? 1, 2, 3. So my answer, how many significant here? 1, 2, 3, 4, 5, 6. This cannot be like this, yeah? So my answer should look like this number, 3 significant figure. So 11.1. I just use this. I don't use those digits there. Make sense? So this is 3. This is also 3 significant figures. So if you are doing the divide and multiply, look the least number of the significant figure and make your answer like that, yeah? And if you are doing addition and subtraction, you look the least number of the decimal places and make the number like that. So 5 to 10 points in this course, yeah? So if somebody wants to get 100 out of 100, so this is important. All right, so it's done. Now, multiplication division. All right, so now there is a rule of rounding. I think that that slide. Now I'm in the slide number 3. So there in top there is a multiplication division and there is a rounding. So I'm just going to talk about the rules of rounding. Yeah. So if you have to round number like this, 2 point. Let's say this is 2.562. So how many significant figure here? There are 4 significant figure, right? So there are 4 significant figures. Now I just want to this number is a 2 significant figure, right? Now I need to round it. So let's say I want to round it here. I want to round it here. So 6. So 6 is, you look like here. So 5, 6, 7, 8, 9. So if you are, so here I want to round it here. So here, I look this number here. So this is 5, 6, 7, 8, 9. So in this position, if there are 5, 6, 8, or 9, so I just cross it and I get 1 here. So that is 2.6. Yeah? That's how we round, right? So then if I have something like this, so 4.35, so 4.35, now I just want to round it here. So I want to make one three significant figure. I want to make it 2 significant figures. So this number here, 5, right? Yes, 4.35. So I want to round it here. So this is 5 here. So 5, 6, 7, 8, 9, right? One of those numbers is right here. So I cross this one and I add 1 here. So that is 4.4. Make sense? Yeah? Now, how about this one? If in that position, let's say we have 0, 1, 2, 3, 4. So I already talked about 5, 6, 7, 8, 9. Now I'm going to talk about 0, 1, 2, 3, 4. So let's look at there. So I have a 4.23 here. I have a 4.23 here. So I want to round it here. I want to round it here. So I'm not here. 5, 6, 7, 8, 9. So this 3 is 5, 6, 7, 8, 9. Not that number, right? So I have just one of those numbers. So 3 here. So I just cross it, and that is 5.2. Make sense? So if you have a 5, 6, 7, 8, 9, you just cross that and add 1 to front number, right? And if you have a 0, 1, 2, 3, 4 there, you just cross it and just drop that. Yeah? This is the rules of rounding. Good. So, now a couple of problems I take from book. So let's practice those problems. 0.12, 1.9, and 925. So this is in your book. So I want to add this number. 0.12, 1.9, 10.925. You don't have to do with hand. You just put those numbers with the in the calculator, and calculator gives the answer, right? So your calculator will give 9.45. So this is not the answer. Although the calculator gives one, this is not the answer, right? So the answer should be looking like this. Here is a 1 decimal place. There are 2 decimal places. Here 1, 2, 3. So my answer should be like the least decimal places, right? So my answer should look like 1.9. So I just drop this. So I just drop this one, 12.9. Make sense? Just 1 decimal place. I don't even care the rounding, as long as you know the significant figure, that's fine, yeah? So if you know how to round, that's it, it's better, but if you don't know how to round, that's fine, yeah? If you don't know how to round here, that's okay. So 12.9 is the answer. Why? Because it's a 1 decimal places, so I also have a 1 decimal places in that, yeah? Good. So let's look another here. So this is from the book. So here is a division of 0.01208, and I divide the number with the 0.0236. So I'm just dividing here. Put those numbers in calculator and divide, and your number in calculator comes like this. So 0.51186. The calculator gives this. So now we need to take care of the significant figure here. So this is a leading 0. This is not significant. This is also leading 0, not significant. So all other is significant. So how many significant figure here? 1, 2, 3, 4. 4, 6 here. How many here? So this is leading 0. This is not significant. This is not significant. So I have only 3 significant figure here. 3 significant. This is 4 significant figure. This is 3 significant figure. So my answer should be least significant figure, right? So how many? So this one is 1, 2, 3, 4. So this is not significant. Leading 0 is not significant. So my answer should look like this. So that is 0.511. So 3 significant figures, right? So 0 is not significant. 511, 3 number are significant, right? So you see that? It looks like this one. 1, 2, 3 significant figure here. So here also 1, 2, 3 significant figure here. Yes. Yeah, you can round it. Yeah. So this was, you could make a, since this is 8, it's greater than 5, right? 5, 6, 7, 8. So what you could do is you could just drop it, and then you can add 1 here, and that would make you 0.512. You can make it 0.5122, but it really doesn't matter. I will not put something like this. Yeah. So the significant figure, the number of significant figure is important than rounding here. Yeah. Good. So now, this is more like a laboratory question. So the mass of a book is, here is the number C. The mass of a book is 13.56 grams. So you have a book and you measure the mass, you put in the balance, and the balance is 13.56 grams is the mass, right? So this is the number C. I'm in slide number 4 and C. Yeah. And then you measure the length of the book. The length is 6.45 centimeter, and then breadth is 2.5 centimeter, 50 centimeter, and height is 0.31 centimeter. So something like this. So this is a mass. You measure you take the book and put in the balance, and balance is this number. And then you measure with the scale, and you measure length, measure breadth, and measure height. Now your job is find the density, right? So the density is, mass divided by volume. So we'll do this in the lab, yeah? So mass divided by volume. So what is the mass? Mass is already given, so the volume. We need to find the volume. So let's volume. So volume is length multiply breadth multiply height. So that is 6.45 multiply 2.50 multiply 0.31. And then you get, if you multiply those numbers, you will get 4. Put in the calculator, 4.99875 cubic centimeter. So something like this. So you got the volume of the book by multiplying length, breadth, and height. Length, breadth, and height, you multiply those, and you got this number in calculator, right? Can you write something like this in this course? No, right? So we need to take care of the significant figure. Now, how many significant figure here? We are doing multiply. You see here, 1, 2, 3 6 here. How many 6 here? 1, 2, 3. The behind 0 is a significant, right? 3 significant figure here. This is 3 significant figure. This is 3 significant figure. This is 2 significant figure. 2 significant figure. You see here, 0.31. The leading 0 is not significant. 3 and 1, just 2 significant figure, right? So my answer should be this significant figure, right? So my answer should be 1, 2, 3, 4, 5, 6. Not like this. Just 2 significant figure. 4.9 cm3. Like this. Yeah, 4.9. The least number of significant figures. So, or you could just round it here. So you could round it like this. So this one, you want to round it here. So you want to drop all this number, and since this number is 5, 6, 7, 8, 9, so one of those numbers. So you could also add 1 here, and if you add 1 here, so that would go to become like a 5.0. Yeah, if you round it. But even if you don't want to round it, that's fine. Yeah, good. So that's it, 5.0, or you can write 4.9 or 5.0. Either is good. So I'm going to write 5.0 here, cubic centimeter. So I got the volume. Now my job is to find the density. Density is equals to mass divided by volume. I have a mass here, 13.56 gram, and then I have a volume here, 5.0 cm3. Something like this. Now if you divide this number by this number in calculator, you will get 2.72310. I don't know what you get. Gram of here, cm3 here. Can I report this number like this? No, I can't do, right? Because I need to take care of significant figure now, right? Now, here, how many significant figures? 1, 2, 3, 4. Here, 1, 2. That's 2 significant figures. So my answer should look like the 2 significant figure, right? Least number of the significant figure. So I just need only 2.7 gram per cm3. Make sense? So in other course, in daily life, if you write something like this, you are 100% good. But in this course, if you write something like, you are going to get 0 in that homework. Yeah? Make sense? So this is the right answer, 2.7 gram per cm. This is the significant, according to significant figure. Make sense? Because there are 2 significant figures. This is the least number of significant figure. there is more. 1, 2, 3, 4. This is 1, 2. Just two significant figures. So my answer should be two significant. Yeah. So this is the rule of significant figure. So the idea is your answer. This is too accurate. You see, this answer is very accurate, right? So many number after the decimal. This is very accurate answer. This is the least accurate number. So your answer cannot be more accurate than your measurement. Yeah. So this is. So the idea is that one. So good, we are done. So this is about 5, 10, 15 points. How many points? I don't know. Yeah. So that's the rule of significant figure. Now, how to do scientific notation? I just so I taught this course last time. I was a little bit nervous. This time I feel a little bit more confident because I already taught this one time. Yeah. So now you have a number like this, 32400. So I'm in the slide number 5. So if you have any question, just ask please. So you have a number like this. Now I want to, this is a, how many significant figure number this one? So this is a very big number, right? So these two are not counted as significant number. So only these three are counted as significant figure. So I want to convert this into a scientific notation. So let's say I want to write somewhere a decimal. So I want to put decimal here. So like this. Where did I put the decimal? Right here, right? There was no decimal. I want to convert, express this number is a decimal number, right? So how do I convert that? So I do like this. So how many steps I put the decimal here? You see that? 1, 2, 3, 4, right? So right here, right? So I started to counting from the back here, and I moved to four step. 1, 2, 3, 4 step here, and I put the decimal there, right? So if I do that, so what I can do is 10 to the power. How many steps I move? Like 4 steps, like that. Yeah. This is how we convert the number into the scientific notation. So if you move your decimal, if you move the decimal for like this, you are going to write just 4. So let's write another number here. So I have a number here. Let's say I have a number C here, 0.001. So something like this, very small number here, right? So I want to put this decimal back here. I want to put here, that decimal I want to put that one, right? I'm just trying to push that decimal the other way. So if that is the case, 1.2, how many steps there I push the decimal back? 1, 2, 3. So 3 steps, and then I put minus here. Make sense? So if you put the decimal forward, so suppose here you was a decimal, you don't know, maybe there was a decimal. So if you want to push this decimal this way, and you want to put the 10 to the power 1, 2, 3, 4, how many steps you push the decimal here? Just put that number there, right? Now, if the number is given like this, 0.0012, and you want to push this decimal backward, so you want to put here, so 1.2 here, so start counting from here, 1, 2, 3. How many steps you push the decimal backward? That's going to the minus. Make sense? So if you push the decimal backward, you are going to put the minus in top. But if you push the decimal forward, you are going to put the plus. You don't really have to put the plus here. So if there is nothing, that's plus. Make sense? So that's how we convert decimal to decimal number to power, scientific notation number. So this is scientific notation, this is scientific notation. Now, how many significant figures here? 3 significant. One is coefficient is significant, right? So these are not significant. So how many significant figures here? These 2 are 2 significant figures. These are not significant. Make sense? So I already wrote this thing. So when you go home, you just read it. Yeah? You don't need to study too much. You just need to have some tricks. Yeah? So let's do this one now. We still have time, so I am in now. All right, so let's talk about the So now I'm in the slide number 6. So there's a term called accuracy, accuracy, accuracy and precision, accuracy and precision, precision, accuracy and precision. Yeah. So what is accuracy and what is precision? So you go to the laboratory and measure one thing 5 times. So let's say you have this duster, and you go to the laboratory and you want to measure the mass of this duster. Put one time in the balance, and you get something like this. So first time you get, maybe this is a 6.23 gram, 6.23 gram, right? Now measure again. So put this duster again in the same balance, and maybe your balance was 6.25 gram, and then measure again, put this again in the same balance, take out and put back, and maybe you got 6.27 gram. So see, your number are very close to each other, right? 6.23, 6.25, 6.27, very close to each other, right? So this is called the precision. So if you are measuring something multiple times, and all number comes to very close to each other, and this is called the precision. Make sense? So yeah, I wrote here, your measured values are close to each other, meaning they are very, very precise. Yeah, precise. So these are very precise, very good precision. Good precision. Let's say good precision. Precision. Because these numbers are very close to each other. You are measuring one thing, you measure multiple times, the number comes to be very, very close to each other, and it's called precision. Yeah. So precision is very good. If you go to the laboratory and you start to measure something, and you measure like precisely, you measure multiple times, you get the same number. Yeah. So this is called precise. Now, somebody already, the company who make this duster say the mass of this one is 6.30 gram. So this is called true value. True value. True value is, so a lot of people, the big company measure this one, make this one, and in their fancy lab they measure this one, and they found this one, and they reported this number to us. Yeah. So this is called a true value. So this is a true value of this duster, and these are our measurements. Are we close to true value? Of course, we are very close to true value, right? This 6.30 is a true value of this duster, the company told us, and we got very close to their number here. So we are accurate, very accurate. Our accuracy is very high because our number are very close to the true value. Yeah. So who measured this one? It's a very, very big laboratories, or they measured this in reported in the website. Big laboratories. These numbers are very. This is the true value. So these one are we measure in our laboratory. Yeah. So if our measurement is same as the reported value by other people, this is called, our measurement is called accurate. So this is called the accuracy and, yeah. So let's say the company says their value was 8 gram, 8.0 gram. So the company says the mass of this duster is 8.0 gram, but our values are 6, right? So we are not accurate in our measurement. Our accuracy is not good. Yeah, we are precise. Our values are very good to each other. They are very close to each other. We are precise, but we are not close to the true value. So our result is very good precision, but accuracy is bad. Make sense? Yeah. So if you measure something and your all values are close to each other, so they are precise. But if those values are very bad, so that's not good precision. So let's say here are some examples, and I'm going to talk about this one. So we will do this in the laboratory. So if you look at the slide number 6, the density of water at room temperature, density of water we'll do in the laboratory M106. So density of water people have reported is 1.0 gram per cubic centimeter per cubic centimeter. So if you take the 1 cubic centimeter water and measure the mass, you will get a 1 gram mass. Yeah. So this is the true value. Density of water is 1 gram, 1.0 gram per cubic centimeter. This is true value. So anywhere you look it, they always write this number. So this is the true value. Yeah. So now we can also measure the density of water in our laboratory. So if you measure, so this is the true value people have reported. So our values are like this. So you got 1.92 gram. One time you do 1 cm cube. Another time you got 1.95 gram per cm cube. Another time you got 1.94 gram per cubic centimeter. So these are our numbers that we measured the density of water in our laboratory. Yeah. Our numbers are very good, 1.92, 1.95, 1.94, these numbers are very close to each other, so we are very precise in our experiment, right? Very precise. We are very precise. These numbers are very precise. Good precision, precise. But are our number close to true value? No. True value is 1, but we are getting almost double. 1.9 is almost 2, right? Yeah, so our accuracy is bad. Accuracy of our measurement is bad, not good. Accuracy is not, because we are supposed to get about 1, but we are getting about 2. Yeah, make sense? So in accuracy, we are comparing our own values with each other. In precision, we are comparing our values with each other. But for accuracy, we are comparing our values to the true value. Make sense? So I might give a few data and say, okay, are these measurements precise, or are these are your measurement is accurate or no? So something like this, yeah, true or false, something like that, yeah. So very precise, not accurate, because actual value is 1. So there is another way of writing this. How much time I have? I still have about 10-minute time. So I still have some time. So let's say another way of people also write it like this: the bullseye. So your true value is this one, and you have a circle here. One circle, another circle, another circle, like this. Yeah. So people also represent accuracy and precision is like this. Yeah. So. So you hit this arrow, you hit this bullseye with the arrow, so multiple times, and you hit, like, let's say 1, 2, 3, 4, 5, 6 times. You hit this bullseye with the arrows 6 times, and this is a true value, right? You want to be here, right? So your values are very close to each other. 1, 2, 3, 4, 5, 6. Your values are very close to each other, right? So you are very precise, and your values are very close to where you want to be, right? You are accurate. So this is accurate as well as precise. Make sense? So let's say another person, so this is a bullseye, and then so you want to hit here, but all the time when you are hitting this with your arrow, you hit here. 1, 2, 3, 4, 5, 6. So yeah, so here you wanted to hit here, but you are hitting here, right? So you are very good. You are very good here. So you are precise, but you are not hitting where you should hit. So here you are precise. You are precise, but not accurate. Not accurate, because you are supposed to hit here, right? But you are hitting all the time here, very precise, very close to each other, but you are not hitting where you should be hitting, right? So this is precise but not accurate. This is precise but not accurate. This one is precise. All values are close to each other, precise as well as accurate. Very close to where you need to hit. Precise and accurate. Yeah? And precise. Okay, so now let's do, this is good. This is good, you know. So if you try a little bit, you probably can hit here. So we try to be precise first. Rather than being accurate, we try to be precise. Yeah. So precision is good, but if precision is bad, we are lost. Yeah. So precision is always good. So let's say something like this here, and so you hit one time here, another time here, another time here, another time here, maybe another time here, 1, 2, 3, 4, 5, 7. Is this good? This is definitely not good, yeah? So you are, one was close to accurate, but I can't trust that. Maybe that's just the random hit, right? So this is neither precise nor accurate. So no precision. This value is this value, this value, this value, this value, far away each other, right? So not good. This hitting is not good. So this hitting is good. So maybe you can try a little bit and you can hit here. But if you start to hit like everywhere like this, that's not good. So this is not precise, not precise, not precise, not accurate, not. So if you look the picture in the internet, so some people write like this, yeah. So your number very close to each other, very good, precise. Your number are close to each other as well as close to true value, precise and accurate, yeah. But if your value are far away like how we are sitting now, that's not precise, right? It's less precision. Good. So we want to be precise and accurate in our experiment. But rather than trying to be accurate, we try to be precise first. If every time we measure something and we are getting the very close value, we are doing very, very good, yeah? And then later on, we will figure out how to be accurate. So precision is always good, yeah? So if you cannot be precise, that's bad. Make sense? Good. So I have few more minutes, then so you can read yourself. I think that's pretty much self-explanatory there. Now, this one is a very. So I'm in the slide number 8. So this is the last slide today. So some math tricks here. So I just want to show some math tricks. So you must understand this one. Without doing this math tricks, we can't do anything. Yeah. So I'm now in 8. So slide 8. So let's say you have a 2 kg of. I think you already know this this in high school or other courses. So this is convert 2 kg to 2 grams. So 2 kg water. Now your job is to convert it into grams, right? So this is simple, but this is very important. So there is a conversion factor. So the conversion factor is given to conversion factor. Conversion factor is here is a 1 kg is equals to 1000 grams. 1000 grams. So these things are given. So your job is to convert 2 kg into grams, and conversion factor is 1 to 1000 grams, right? So any question here? Alrighty. So I write the 2 kg first here, and I want to convert into the grams. So you just multiply here, and what do we need? We need grams. So put this factor in such a way that you want to cancel the kg, right? So I need grams. So I'm going to put this gram part in top here. And then I don't need kg, so I'm going to put this factor here, 1 kg here. So kg cancel here. So this multiply this 2000 grams, right? These grams. So like this, yeah. So whatever you need, put that factor in top. So you need gram. So you are going to put this factor on top and the another in down, so that that one cancel, and then you get the answer, right? It's very simple, but it's very important, yeah. So without knowing this one, we can't do anything, yeah. Good. Now let's do another one. So convert 100.0 grams. So here is a 100.0 gram of water to moles. So this is, I will explain what is moles later, but I just want to give how to do the conversion here. So convert 100 gram of water into moles. So conversion factor here is 1 mole of water. 1 mole of water is equals to 18 grams. 18 grams. So our job is to convert 100 gram of water to moles, and conversion factor is given as 1 mole is equals to 18 grams. Now I'm going to put this one here, 100.0 gram, and my job is to find gram or mole. Our job is to find the moles, right? Yeah, so moles. So I need to put the moles part in top here. So this 1 mole part up there, and then gram part here down, 18 gram. So the gram cancel. Yeah. So whatever I don't want, I just want to put that part down so that I can cancel. Yeah. Now you just put those values in calculator, and you will get 5.555 moles. So only mole is remaining here. Gram I don't need here, right? I just already. So I don't you really don't have to consider here this significant figure here. If I want that significant figure, I will clearly state in a question, or you just whatever number comes here, just put here. So it's 5.5 moles. Yeah, 5.5 moles. Yeah. So if I want something like the significant figure, I will clearly state in question. Okay, put that your answer in according to the rule of significant figure. But if that is not said there, so you can put whatever you like, whatever the calculator gives there. Yeah, make sense? Great. So I think we are done for today's class. So hopefully you understood something, and we'll continue. Yeah. Great. Thank you very much, everyone. All right, online people, I have not forgotten you. So if you have any question, you can bring later, or you can email me. Yeah. All right. Good. Thank you very much.